Alright, Daniel Pilots, I hope you're doing wonderful as you're watching this series on IT systems. In this part, we'll be covering fire and smoke detectors. I hope you have watched the previous parts. Let's get started. So, first thing first is a fire triangle. So, what is a fire triangle? You might have studied this in your early classes, right? So what is a fire triangle? It is made of three elements. Firstly, we have oxygen, then you have a heat source and fuel. So when these three things are present together, they will produce what? Fire, right? So if any one of this element is removed, for example, I remove oxygen from this triangle, so only heat and fuel cannot produce a fire. The fire will extinguish, right? And just like that, if I remove heat or fuel, then the fire will extinguish, right? So if any one of these elements is removed, the fire will extinguish. This is a fire triangle and it is very, very basic. Now we have fire detectors. So there are three types of fire detectors that we have to study. Firstly, there is a differential expansion detector, then there is a firewire detector, and then a gas fill detector. All right. So let's start with a differential expansion detector. Does the name suggest differential? That is means what different. Expansion means again, you know what expansion is, right? You're stretching something, it is expanding, right? That is expansion, and it's a detector. So the principle of operation is what when heat is applied to different materials, they will expand at different rates, right? So all of the materials, when you apply heat, they'll expand, right? If I have an iron rod and I apply heat to it, then it will expand, right? And if I have a steel rod, for example, it will expand at a different rate, right? So different materials they expand at different rates, right? So this is the sole principle of operation of your differential type detectors that the whenever the heat is applied to different materials, they'll expand at different rates, right? So in this diagram, you can see that we have an expansion tube. So this black colored thing that you're seeing here, this black colored body is a expansion tube, right? So this expansion tube will expand whenever the heat is applied to it, right? So in the second diagram, you can see that whenever the heat is applied, right? In this case, the heat is applied. So this tube has expanded, right? It is expanded upwards and downwards, right? This has caused what? This has caused the inside metal because it was made of a different material, so it didn't expand that much, and this caused these contacts to be made, right? So these two conducting material, these silver colored material that you're seeing, they come in contact, right? As they come in contact, the circuit got completed, and hence there was a warning in the cockpit, right? So the pilots can now know that there is some heat source that has caused these to expand and hence triggering a warning, right? So these is how your differential expansion detectors work. And if, for example, I remove the heat, then what will happen? It will come back to its original shape, right? The expansion will be gone. It will come back to its original shape. And what will happen to these contacts? They will move apart, right? So there won't be any contact and the light will extinguish, right? So they help us in detecting fire and also when the fire is removed. Now, uh, yeah, when the heat is removed, the alarm will turn off as there is no contact. I've already told you that it is again in the normal position because it is come contracted again, right? So this is your differential expansion detector, and there is a time delay which is used to prevent a false alarm, which is caused by vibration, right? Obviously, these two parts are not very far apart; they are almost close, right? So, for example, there is some vibration, right? It is a dynamic body, so the aircraft can have vibrations, right? So due to some vibration, if these two materials made contact, right, for even once, the light will blink, right? So they might confuse the pilots whether there is a fire or no, right? So that is why there is a delay fitted in between this circuit. This delay will be there, it will measure for how long these two contacts were made. And if this was long enough, then only it will let the pilot see the warning light. All right. So this is your differential expansion detectors. Now the second type is a firewire detector. So what is a firewire detector? It uses a negative resistance coefficient. What is a negative resistance coefficient? So these are some kind of special materials on which if you apply heat, right, if I have this as a negative temperature coefficient material and I apply heat to this material, then the resistance of this material will start to reduce, right? So if I have a wire, right, and I am connected it with some circuit, right? So this is my circuit. Now this wire is there, right? So if I apply heat to this wire, right, and I'm measuring my current over here, for example, there is an emitter over here. Emitter is used to measure current, right? So in this case, what will happen as I apply heat to this particular negatively temperature coefficient wire, then the resistance of this wire will reduce, which means what? There will be more current. So my emitter will start to read more value, right? This is your negative resistance coefficient materials, and it is used in your firewire detectors, right? Remember this, very important, right? So as the temperature increases, the resistance decreases, which causes extra current, right? So as you saw that in this case, the emitter reading was more. And as the resistance decreases, the current increases, hence the warning in the cockpit, right? So as the current increases, so it is sensed by your alarms and your alarm starts to blink and there is a oral warning in the cockpit, right? So they primarily work with the help of what? Negative resistance coefficient, and whenever there is a rise in the temperature, the resistance decreases, which increases the current, and hence there is a warning in the cockpit, right? So this is your firewire detectors. Then we have a gas field detectors, right? So these kind of detector works with the help of a pressure switch, right? So there is a core element, and it is used which produces hydrogen, right? So this that you're seeing this thing is a core element, and it is inside a tube. So what happens is when you apply heat, right? When you apply heat, what will happen? This core element will start to produce hydrogen gas, right? So the hydrogen gas will be produced by this element and it will fill up this tube, right? So as the heat is applied, it is producing hydrogen gas, which will fill this tube, right? And as the tube is filled, what will happen? There will be an increase in the pressure, right? So this pressure will be sensed by this pressure switch. And as the pressure is sensed by this pressure switch, they'll know that the pressure has increased and will trigger a warning in the cockpit. So the pilots will know that there is something that is causing the temperature to increase, right? They'll know there is a fire, right? So this is your gas filled detectors. There's not much you need to know about these kind of detectors. Just an overview, all right? Now, the fire warnings. So, what are the fire warnings in the cockpit? So, whenever the system is used, the fire warning in the cockpit will be both oral and visual, right? So, whichever system you use, be it your what we studied, your gas fill detectors, be it your differential expansion or firewire detectors, there will be always a oral and a visual warning, right? So, there will be sounds, there will be bells in the cockpit, and there will also be lights in the cockpit, right? So there are always oral and visual type of signal. This is also a very important question for your exam. Remember this thing, right? And the fire warning is tested before each flight. So this panel that you can see, and this panel, there is something known as a test switch, right? So for engine one, there is a test switch here. You can press this switch and then you can test the warning lights and the sound that you'll hear, right? So it is just to test the system is working fine or no, right? Before the flight, you are supposed to test it, right? Similarly is for the APU. This one is for your engines, engine number two, right? Then there are certain fixed fire extinguishers that are installed in the aircraft, right? So they're usually installed for your engines and APU. So both of your engines and APU have their own separate fire extinguishers built into them, right? So with the engines can have their separate fire extinguisher bottles, right? So in this diagram you can see this is your left engine, right, and this is your right engine. So both of these cylinders have a fire extinguisher bottle. Right, so this you can see is a left fire extinguisher bottle. This is a right fire extinguisher bottle. And there is a button which is controlling these bottles, right? So right bottle and left bottle discharge. So if the pilot presses this button, they'll discharge the extinguishing material inside the engines, right? And the thing about these kind of system is that either bottle left or right can be discharged in either engine, left or right, right? So it does not matter, that the left bottle will discharge only in the left engine. If you want, if there is, for example, a fire in the left engine, right? So you try to extinguish the fire with the help of the left extinguisher. So you press this button and the extinguisher will extinguish this fire. But if, for example, the fire is extinguished and in future, like in the same flight, if the fire starts to again, uh, if the fire is again there, then what will the pilot do? The fire extinguisher is empty here, right? The fire we have already extinguished. So the pilots can use the right bottle discharge, right? The pilots can take this discharge. It is also connected with your engine, so it can go inside your left engine, right? So either one, be it your left or right bottle, both can be discharged into either engine, left or right. Right. Remember this then again, very important. Then you have types of fire extinguishers, right? So there are a lot of different types, as you can already see. We have PCF, BTM, water glycol, dry powder, carbon dioxide, foam, sand. And yes, this might get a little boring, but they are trust me, they're very, very important for your exam. So remember the properties, they usually ask a lot of questions from this topic. So you have to pay attention to this particular part. You cannot skip this. All right. So firstly, we have bromochlorodiafluoromethane or simply BCF, right? And more commonly, it is known as what? Helen 1211, right? So all of these three names, bromochlorodiafluoromethane, I'm not even able to pronounce this. A BCF is also known as your Helen, right? So remember this name, Helen 1211 as your BCF, right? Then you have it is very effective against electrical and flammable liquid. Guys, I cannot explain this, but it is just it is effective. So it is a fact. I cannot find a good logical way to explain this. Yeah, it is there, right? So you have to remember this. Very effective against what? Electrical fires and flammable liquids, right? What are flammable liquids? Your petrol, gasoline, or things like that are your flammable liquids. And it is also slightly toxic, right? And it is colorless, it is non-corrosive, and it does not leave any residue. It evaporates rapidly, right? So this is also a good thing about our extinguisher. And it doesn't freeze, right? So again, at high altitudes, you don't have to worry about that and doesn't harm the metal or fabric. So if you can easily apply it to any metal or any fabric, and there won't be any major problems, right? So these are properties of your BCF, right? Right, so it can also be directed as a liquid stream, right, from a handheld fire extinguisher, hence allowing to fight a fire from a distance, right? So in this diagram, you can see that there is a stream, a proper stream coming out of the extinguishers, right? So if the fire is somewhere here or maybe here, you can literally extinguish the fire just by pointing this it over the fire like this, right? So because it is coming out in form of a stream, it can extinguish a fire with the help of a handheld fire extinguisher, and you can fight the fire from a distance, right? So this is also a good thing about a fire extinguisher. So BCF, your Helen 1211, is a very, very good kind of fire extinguisher that we use very often in our aircraft. Now, the next type is a BTM or bromotrifluoromethane. So BTM has very, very similar property with your LN1211 or BCF, right? So it is commonly known as Helen 1301. Again, a very important thing to remember for your exams, right? So BTM is known as Helen 1301. It has very similar properties with your Helen 1211 or BCF, right? And the only difference that will be there is that it cannot be directed as a stream since it is expelled as vapor spray and hence not normally used for handheld fire extinguishers, but it is used in your APUs and engine and cargoes, right? So yeah, these kind of extinguishers they'll form mist when they are sprayed, right? So they'll form fine mist and hence they cannot extinguish a fire from a distance and hence usually not used in your handheld fire extinguishers, right? And if you have to call PCF and BTM together, then you can commonly call them as freon. So they are what freon type of fire extinguisher. There are a lot more freon type of fire extinguisher, but in our syllabus we have what BCM and BTM. So remember this word freon type of fire extinguishers. So if someone asks you what is Freon, so you can tell them it is your BCF and BTM type of fire extinguishers. All right. Then there is your water glycol. So water glycol is just water actually, right? Because only the water works as an extinguisher. Glycol is just added so that it can reduce the freezing point of water, and it usually drops below 0 degrees, right? So the water, as you all know, if there is a fire, right? God forbid, but if there is a fire in your house, then what do you do? The first thing you rush for is water, right? So water helps in extinguishing the fire. But what is glycol? So glycol is something known as an anti-freezing agent, which is added to water because we all know that the water easily freezes right at 0 degrees Celsius, right? So water, if you want to make sure that the water does not freeze at high altitudes, since the temperatures are low, if the cabin heating failed to work, in those kind of scenarios, you don't want the water to be frozen, right? You cannot throw ice out of these bottles, right? Obviously. So that is why there is glycol added to your water, which reduces the freezing point. So usually it reduces it till around minus 20 degrees Celsius. The water will not freeze at temperatures uh, below your minus around your minus 20 degrees Celsius, right? So that is why glycol is added, and it must not be used on electrical fire, liquid fire, or hot breaks. You might have studied this already and your first, what do you call it, firefighting kind of lectures in some classes, right? Electrical fires, obviously, water plus electricity is boom, right? You cannot combine water and electricity, obviously. And obviously, because water is a good conductor of electricity, right? If there is salt water, then even better. And liquid fire, why? Because we all know that your oil will float over your water, right? And it won't have any effect if you throw water on your oil containing fire, right? If you have a petroleum fire, you cannot use water to extinguish fire. That's why you have sand placed at your fire, what do you call it, petrol pumps, right? And yeah, obviously. And then there is what your hot breaks. So you cannot use water for hot breaks because water is cooling water has cooling kind of properties, right? And if you apply it to hot metal, then the metal itself can develop some damages. It can deform, right? And that is why it is not used in hot breaks. So this is very, very important when very often asked that it should not be used on electrical, liquid, or hot break fire, right? Then the next type is a dry powder type of fire extinguisher. So it should not be used in flight crew compartment. Very important. I'm telling you guys, this is a part which is asked very, very often in your exams. So please don't skip it. And yeah, so they are used in your flight crew compartment. They are never used in your flight crew compartment, right? So you cannot use these kind of fire extinguisher in your flight crew compartment. And the reason is very clear that they reduce the visibility, right? And the powder can run into the electrical equipments, making them unserviceable, right? So hence it is not to be used on electrical fires, right? So if you have a fire in the cockpit, never use dry powder because firstly it will reduce your visibility. You won't be able to see uh, outside, right? You won't be able to see the nice view outside your windows, and also it can run into your electrical equipment. It can get into your buttons and all, right? So it can create problems there, right? So it should not be used in flight crew compartments or any other compartment which is not separated by the flight crew. Makes a very obvious sense. If you don't have a door in the cockpit and there are two compartments, you cannot use fire extinguisher here because if there is no door, the extinguisher powder will rush into the cockpit and it will do the same effects, right? So it's very obvious. Right. So it is again non-toxic powder. It is very effective against liquid, wood, fabric, and paper. And the best for wheel, and this is very, very important. That's why I have kept it in bold. So this is best for your wheel brake fire as it does not cool the brakes, unlike your water. So no risk of explosion or distortion, right? So this is again very important that dry powder is used for your hot breaks kind of fire, right? Very, very important. Trust me. And then you have carbon dioxide. So it is a non-corrosive, non-toxic gas and should not be used in a closed compartment, right? You can suffocate with this, and it cannot can be used against most type of fire, right? It can be used against most type of fire, and it can be a suitable substitute for your dry powder in case of a wheel brake fire, right? So it makes sense. It makes itself very clear that it can be used as a substitute for your dry powder kind of extinguisher, right? So in case you have a wheel brake fire and don't have your dry powders, then you can use your carbon dioxide, right? And the important point to remember here is that it should not be used for a closed compartment. And then you have your foam and sand. So foam is best for flammable liquids. It blankets the liquid and hence cuts the oxygen. So again, self-explanatory, right? And you have sand, which is best for your metal fires, right? So remember these points if you can. Very well asked in your exams. And then finally, we have smoke detectors. So there are two types of smoke detectors. Firstly, we have an optical detector, and then there is a ionization detector, right? So let's see the optical detectors first. What are optical detectors? So they use a photoelectric cell and a light source. So this is very simple kind of working it has. So see, this is a photoelectric cell. What are photoelectric cells? So they are a cell which produces electricity whenever we throw light on them. So if I have a cell and I put some light on it, then it will generate electricity, right? So these are known as your photoelectric cells, right? So we use photoelectric cell in your optical detectors, right? So what happens? See, we have a light source over here. So this is our light source, right? This thing that you're seeing here is a light source, right? And then there is a opaque barrier. So there is a barrier here, right? And there are certain spokes kind of things so that they can assist the refraction of light that we'll see how and why, right? So the whole concept is that the photoelectric sensor is kept in pure darkness, right? So as you can see, because of this barrier and because of these restrictions, there is no light on your photoelectric sensor, right? The photoelectric sensor will not be producing any electricity, right? But if there is smoke that is entering the cabin. In the second image, you can see that the smoke has entered the cabin, and this smoke has caused what? Scattering of light, right? The light will scatter because of this smoke particles. The light will go here and there, it will bounce, right? And some light will reach your photoelectric sensor, right? And this will cause what? Photoelectric sensor to produce electricity and it will then have an alarm system attached to it, and obviously there will be alarm, and we'll know who was there in the laboratory smoking a cigarette, right? So when the smoke enters the chamber due to a scattering of light, it hits a photoelectric cell producing electricity and hence an alarm, right? I have explained this in the most simplest terms I could, right? So then we have ionization detectors. So they are a little complicated. It uses a radioactive material and oppositely charged plates, right? So as you can see here, we have a radioactive material, and radioactive material does what? It produces alpha particles. So these alpha particles are produced with the help of these radioactive materials. That it will be constantly producing what? Alpha particles, and it will ionize the air around it. It will ionize the oxygen and nitrogen in the air. So there will be obviously oxygen and nitrogen all over the place because this is what our air is made of, right? And these oxygen and nitrogens will be ionized, right? How will they ionize? That we don't have to go through that, but these air molecules or the oxygen and nitrogen will get ionized, and when they're ionized, they'll convert into electrons, right? So they all are negatively charged, and these electrons will obviously be attracted towards the positive plate. So this is a positive plate and this is a negative plate, right? So the electrons will be attracted towards the positive plate. All of these electrons will go here, and it will create a continuous flow of electron. And you might be knowing what a flow of electron is. So it is current, right? So the electrons will flow around the circuit and it will be producing a small amount of current, right? But when there is some smoke enters the cabin, right? If there is some smoke molecules that enters this chamber, then what will happen? That it will disturb this flow of electron and hence reduce the amount of current that is being produced, right? This change will be detected by the sensors and hence it will trigger an alarm in the cockpit, right? So these ions are negatively charged, hence attracted by the positive plate. As we have seen, the positive plate was attracting these ions. Whenever the smoke enters the chamber, the flow of the electron is distorted and it is sensed by the control circuit, triggering an alarm. Right? So no need to go in the details, just an overview about these kind of detectors. Alright, so that's it for the smoke and fire detectors. And announcement time that the description is having a link which you can click and you can join the live classes in which we will cover principles of flight. We will do engines and electrics, right? So if you want to study all of those parts because they are again for your DGCA exams, obviously, right? So if you want to inquire about the classes, just go and fill up the form. I'm just asking your name and number, right? That's it. Just click on the link, fill up the form, and I'll talk to you there. All right. Bye bye. Enjoy.